Hello, welcome to a new episode on building the Funq DI container using TDD. In this episode, we will work out improvements on the Fluent interface that we have for the registrations. Right now, it's a very simple API that we have. Basically, we can register, we can name things, and then assign reuse, scope, and ownership. The problem with what we have now is that, for example, if I do the register, let's go and create a new test. It's not going to test anything, so I'll just call Fluent API. Builder. Now, when we call builder register, we can assign a name. Now the first problem is when after we assign the name, we don't have anything here, so the dot is empty, and basically that's because the named method returns void, so we should return something here so that we can continue calling methods on that. So the first thing is you just return the same thing all over the place. So return this, so you return yourself so that you can continue calling methods on that object. So that's how you get the, how do they call it, the train, chain, something like that. So name, then I can say like reuse within, and after that I can say owned by, and I could keep calling that. So the first thing is we are so when you are tracking the invocations on a Fluent API, basically you have an object that internally keeps the state of whatever has been called so far. So you basically store the value, for example, for the reuse scope, and then return yourself, and those values go into properties. Now, if people see those properties there, that might be confusing, because then they might say name equals so name, and now. So that means that they could use your API in two ways. They could basically declare a variable for the registration and then do reg.name equals foo and so on. And maybe you don't want that to happen. So you would want to have a consistent API use throughout your project, so that you don't have some developers using the property setters and some other developers using the Fluent API. So the first thing we're going to do is create the interfaces for that. We'll put all those in a single file called syntax. And the way I typically work this out is I have one interface for each Fluent verb that I have, and then I start composing those verbs as they make sense or not in more interfaces. So let's see. When you do a register, you want to be able to do any of the three things, right? You should be able to name an instance, or specify the reuse or the owner, and you could do any one of those without the others. So you should be able to do that, correct? Or you should be able to do that or that, okay? So it shouldn't impose any restriction on that. So the first register should return all the verbs. So let's go and add the interface for the verbs. So let's do public interface, and let's start with the named. I named. So I named defines what? The verb public. Let's make it void, and let's work out what should be returned from here. String name. Then let's add the interface for the other verbs, which are the I reused, which basically does the reused within. Okay, and finally the interface for the I owned. Owned by and owner. Okay, so now let's see if we have already named something. We shouldn't be able to name the same thing twice. So what we return from named should be the combination of the two remaining verbs that we can use. So that would be so we'll start composing the interfaces up here. Public interface, and that should be I reuse owned. And basically this simply exposes I reused and I owned. Okay, so that's what we return from here. I reuse owned. Now, when somebody calls, so you have to define what is the API you want to have, the consistent experience. So the other thing is when somebody calls reuse, and you can be prescriptive on this. So I can very well say that naming can only be done at the beginning. Okay, so that you can have a consistent experience whereby you will never have something like this in one place and something completely opposite on another place, because that also makes it harder to look at the configuration for your container and have a consistent usage, right? So it increases the friction when you read the code. So if you have always the same predictable steps, that's better. So let's go one up, and let's say, what does the registration expose? Well, basically the interface for the I registration is all of the others. I named and I reuse owned. So when I'm doing the registration, I can call any of those things. Finally, let's go next to the next one, which is the reuse. So when I call reuse within, the next thing that I should be doing is setting the owner. So this should return the owned. I owned. And finally, owned by is going to be the last verb on our Fluent API, so that means that it's void. So let's see how this works out. The first thing we have to do in order to replace this is basically have the registration implement our new I registration interface. We can now make this internal if we want, and what we can do is have our container builder return I registrations instead. And now, because we return I registration, now all of the properties will be gone. Okay, so now the use for the API will be simpler. Now we have named, owned, and reused. If we call named, what we can do next is owned and reused. If we do owned, now we cannot do anything else. Okay, because we are done. This is void. This is the last verb on the API. Or we can do reuse within, and after that I can still do owned. But I cannot name the thing after I got to this point. So that's how you basically build up a Fluent API. You just, or that's the way I do it at least. I create one interface for each verb, and then compose the verbs into basically the language interfaces. So these are the ones that expose which are the combinations, and finally you have the entry point. Now one interesting bit that I'm going to add here is I blogged about this before, And something which is very key in order for this to actually be very usable is okay, we need to change the return types on what the registration is returning, because it's returning iRegistration should be returning itself. Actually, we should be returning what the interface says that we should return. So named should return I reuse owned. Reuse within should return I owned. And owned by should return void. It works. Now, there are a couple of things here to take into account. First, when somebody adds a reference to your library, let's go and create another window, Visual Studio, and let's say I go and create a new console application. So when developers that are using your library add a reference to your library, basically all the public interfaces are going to show up, and you want to have as small an API surface as you can, because that decreases the learning curve and also makes your product look simpler, and it should be easier to learn if you have less APIs to work with. So let's go create a console application, and let's add a reference to our Funq library. Let's go over there. And I am doing this from the outside because when you have the project within the same solution, in the same Visual Studio window, IntelliSense behaves a little different. So let's go func bin debug here. And now when somebody does func dot, now they will see all those interfaces that we created just for the purpose of having a nice API, and that's not very good. So the first thing we'll do is hide those. How do you hide them? There's an editor browsable attribute here from the system component model, which allows you to say that the browsable state is never. So that means that it will not show up on IntelliSense. So let's see if that's the case. I don't remember if I have to restart Visual Studio or close the solution, reopen. Let's do a rebuild. Let's see if we remove the reference and add it again, if that makes the trick. There we go. So the interfaces are now gone. That's one thing. The other is, let's go to the builder. Now when we do builder.register program, okay, now we are getting the equals, get hash code, get type, toString, which really don't make sense also in a Fluent API. And I also blogged about that on my blog at some point. The trick there is to have what now everybody is calling iFluent interface. It's basically a class where you can apply the editor browsable attribute to the system object members. So what you basically do is create a new interface. You make it editor browsable never. Correct. And now you start adding all the members from system object. And what you do is mark them also as editor browsable never. And Visual Studio, this is just a nice trick that I don't even remember how I found out. But Visual Studio will basically pick the attributes on the not on system object, which doesn't have these editor browsable attributes, but it will pick those from this interface if you happen to be inspecting an object that implements this interface. So what we do now is we basically have all our Fluent API basically implement that Fluent interface so that all of them now have those attributes on the system object members. Let's recompile. Let's go back to here. Let's remove and re-add. See if it works this time too. Excellent. So now they are all gone. So we don't have get type or equals get hash code and toString. So the API looks very, very clean now, and we have our deterministic, if you will, API usage, where options start shrinking that down as you use them. Okay, so now we can guide our developers, our users, on how to basically configure our objects using our API. So that's pretty much it for building the Fluent API. So that's how I do it typically. This is how we did it in Mock, and same thing applied here in Funq. So this is going to be a short episode. I think this is enough for today. We can get rid of all that except for the component model. So what we did is clean up the Fluent interface. We made the registrations members return the interface for the Fluent API rather than the internal registration class, which we now keep internal as it should have always been, and so nobody gets to see the properties or the internal state or anything. So thanks, and on the next one, I don't even know what we are going to add because it's pretty much a full feature DI container at this point. But we'll see what comes up. Thanks, and thanks for listening so far. Bye.